Right. All right, so we're going to do congruent triangles a little bit. All right. So we're looking at congruent triangle theorems, a little bit more about recognizing what information you know that guarantees that two triangles are congruent, and then just using the fact that they're congruent to get an answer. All right. So as usual, the first page is your practice work. Let's get going. So this first triangle here, notice that the instructions here say determine whether the following triangles are congruent. If they are, name the congruence information that proves it or supports your conclusion. Be sure to show any additional markings if needed or part of your reasoning. So if there's parallel lines that guarantee an angle are equal, two angles are equal, and that's necessary, show that as well. And if they can't be proven, if there's not enough information, then state not possible or not enough info. All right, so let's get started on the first one here. If we're looking, we have that angle is equal to that angle is given to us. That side is given as that side. This one is a common one where it's tricky because there's like hidden information, and the hidden information is that this shared side is the same on both of them. So if you look, we have side, angle, side congruence. Okay, so if that's the case, then you might look and say, okay, well, triangle A, I should do two dashes there for that one, so it's distinct. So going from the end of side one, side with one dash around. So A, B, D is the way this one was ordered. And then we're going from the end of the side one as well, right the other way. So these are different colors, so it's out, right? So at the end of this one, we're starting in that same spot as before and going around to the double. And so that would be C, B, D. Okay, triangle C, B, D. Okay, so if that's known, let's put this, that guarantees congruence. Okay, let's say there was extra information given in this question where they told you that this is 10. And they might be asking, what's CD or DC equal to? Right? You'd be able to figure that out because you'd be able to say that DC is the same as 80, right? And so you could say, obviously here, DC would be half of it, right? The proper way, I suppose, we do this would be to say that AD is equal to DC. So you might say like AD is equal to DC, in which case you could label DC on there. And so we could show like two DCs, right, equals 10. And so DC would equal 5, right? So you'd say like this is because of their congruent triangles, right? So on, as it was already stated. So the way this would go in your work is you do this work first to show that they are congruent, and then say, oh, because of that, we can do this other stuff, right? So the reason for the congruence is that, and then I suppose I could order this. Just use a mouse instead. One sec here. Let's grab this stuff. It's not letting me grab that, but I'll move down here for now. Oh, it's being fussy. All right. So yeah, you know that's true because of your triangles, and again, you just go label your DC on there to make it logical and so on. Right. So that's recognizing and then also using the information. Moving on to the next one. What do we have in this one? Well, we've got side information. We've got side information. We have nothing else, right? And so this one is not enough info because there's just not enough. It's not possible. There's not enough information given. So that I move to here, the old version of things here. This one says you get that side, not possible. Doesn't have enough info, right? The third one here. What do we have for this one? We've got angle, and we have S and S, and we have similarly, or put here, we got angle, and then we have side and side. And it is like the same order and whatnot, so it's, seems like it's good, but the SSA theorem is not a congruence theorem, right? Or the other order of that acronym, if you want, is not a congruent triangle theorem. So really, we're just saying there's not nothing. Reveal that on the next page here, that we have what's called the ambiguous case. To elaborate a little bit more, this little side here could easily have swung out that way, in which case you'd have like a different triangle. I was going to say obtuse or scaling or whatever, but whatever. It's swung out, it would have been a different shape. It's not guaranteed to be congruent. Okay. Moving on to some other ones. This one here, pause the video, try yourself, whatever, and press play once you've decided here. Reason for this one being congruent is side, side, side congruence, right? You've got side, side, side all over the place here. So in order, if I was doing this like side 1, side 2, and side 3, so side 1, side 2, side 3, and you're given all those things, right? So then we have, if I go from, let's go from the intersection of 1 and 2. Let's start there. Intersection of 1 and 2, start there. Okay, if I go around to the intersection of 2 and 3 and cross, then it'd be saying, oh, actually, I better start the way they ordered. The way I just did this, I'd be saying triangle TSU would be congruent to triangle to do it 3 would have been XVW. Okay. They started with STU. So let's do the STU version, and it would have been starting at the 2 and the 3 and going the other way. And so 2 and 3 the other way, 2 and 3 go towards the 1, 2. So go towards the 1, 2. You can tell that would be VXW. Right? So those are congruent. There's not a whole lot could be done for this one. Like if I gave you, maybe I told you this side was 15 or something, then you'd be able to say, oh, WX equals, WX equals TU because of congruent triangles. And so WX would equal the TU value of 15. That would just be the using congruent information part of the work. This question here, the next one, if you look, you have shared side. Don't miss that, but you have that. You have 90 degree here, which actually guarantees that this one is 90 also, because 90 plus, call it angle X or something, that has to add to 180. So you could show easily that that would also be 90 degrees by subtracting both sides. So that'd be 90 as well. So we have so far like side and angle, but even though it looks to be the case, we don't know what these lengths are. They could be different from one another. Even though they look pretty similar, you can't trust the artist. You have to go by what information is given. And we also don't know that these are the same. Okay, so those are not given. And so there's just not. Right? Not enough info, not possible, whatever you want to word it as. This one is pretty straightforward here. Right? You've got your side, angle, side here, and then corresponding side, angle, side here. Ordered like that and ordered like that. So if we went C, D, E like it does here, then you'd go F, G, H. Right? And again, I could give, if I gave this as a 6 and this is for 4, I'm not sure what it looks best as, but if that was 6 and 5, and then I asked you, what's this side? You could, of course, calculate this one using the Pythagorean theorem and then say, well, that one's the same because it's corresponding sides on a congruent triangle. Okay, so yeah, that would work. So this one was side angle side, wasn't it? I can say that again. And so on. So that's what we had done before there. WBXW, is that what I ended up saying? I think so. Right, not enough to only have side angle and then GH and so on. Here we go. This one is BXW, like I said last time as well. And so as we go here, let's do the third one here because it's a little more interesting in terms of what you have to notice and figure out. So this one we have, well, what would you have to notice? Obviously, you're given side and side and side and side. And the thing to notice is that this angle here would be the same as that angle there. So you have angle information. But again, if you look here, you've got side, side, angle. And so that doesn't guarantee congruence the way it is, unless there's some other information I'm missing. I think it would side angle. And so it'd be possible, doesn't look like geometrically it's possible right now, but it'd be possible for this side to swing in and be in here, right? Even though it's actually too long in the drawing. But again, you're not supposed to trust the artist, you're supposed to trust the math that's given to you. So technically that's a not possible case, because again, this ambiguous triangle thing here, this side, maybe you could swing into here and go like that, right? In which case they're not going to be congruent, and so on. Okay. Lots of examples here to practice. Let's go to the possible. Oh, we do a possible one next, right? So let's do this one. So here, obviously, you have side and side corresponding here, side and side. So if we did 1, 2, 2, just like the dashes. And again, the thing to notice here is that you have an angle here and an angle there. So we have side angle side. Right? So if you were given the total length, another one of those ones where I might give you the total length here, there to there, and I might tell you that's 20 or something, or 30 or whatever. That's 30, the whole thing, then obviously you'd be able to tell me that half of it would be 15 if that's what it was asked for, and so on. So first, proving congruence, and then using it. It's the order here. We have HJK, HJK going from 2 to 1 to center. So 2 to 1 to center. Nope, 2 to 1 to center. 2 to 1 to center. So it'd be MLK. Right. And yeah, okay, side to side, right? And you could do a number example as well, right? So let's write this out down here. If given that LJ equals 30, you could say KJ plus LK equals the LJ, which equals the 30. Then you'd have to say that KJ equals LK because of similar congruent triangles. KJ equals LJ. So congruent triangles. And so the KJ would be in there twice. KJ plus KJ equals 30. 2 KJs equals 30. Divide both sides by 2. Up with KJ shown very thoroughly to be 15, justifications of how we did it, and so on. Okay. And that's just a bunch there to practice. I didn't have to go through more of them, I don't think. So the question sheet is here for you. Yeah, so you just have a little bit of work to do each time to guarantee congruence. Say how you know. And then use the information to figure out the missing pieces, whatever's missing in each question. Yeah. The missing sides and angles in that last one, bits and pieces from the other. Right, so as always, message me, email me on D2L if you have any questions. Be sure to watch the video, just try it, and submit so we can keep track of how you do and help you out if you need it. All right, till next time.